All right, girls, listen up. In we have Thursday, I believe Monday and Wednesday, in addition to this class. So definitely Thursday we'll start our review in earnest. Some of you've already started your review, but I mean it'll be class time dedicated to that on Thursday, Monday, and Wednesday. So we'll have 3 good days of review in class. It could be that we have a quiz one of those days on geometric series because I never quizzed you on that, and that'll probably be a good thing. But if we have a quiz, I'll definitely let you know on assignments, and I'll let you know exactly what to study, like what would be on the quiz. So unless you see it pop on assignments, either memo quiz or regular quiz, you don't have it unless I specifically tell you what to do. So we're going to start off with Isabella's question.
Yeah, like 85.
Do you need me? Yeah. Yeah. You may just want to, yeah, my desk is a mess. Yeah. All right, what number?
85.
Oh, yeah, I just wrote it down. Thank you. All right, 85 is 1.25. All right, the easy way to do this, and then after I talk about this, you may want to go back and watch that short video again on repeating decimals. I think I also put it under topics so that maybe you don't have to just scroll back all the time for videos that I've made. But if you're looking for one that you can't find somewhere, just email me and I'll send you the link. Anyway, the quick way to do this is to realize if something's repeating. This would be 1/9. 135 repeating would be 135 over 999. So use these nines to help yourself do a repeat. I only have one number repeating, and so this is the quick way to do this would be 5 over 9 would make it repeat, but I don't want it to start repeating right away, and so I'll put it over 90 and multiplying it the bottom by that 10, multiplying the bottom by that 10 moves your decimal place over. Do you see what I mean, girls? Okay, it's a trick, kind of, but if you watch the video, I totally based each one on the arithmetic series, the sum of the infinite geometric series. Okay, so the quick way to do that, then I already have this like stationary 1 and 2/10 plus 5 over 90. And when I add all these up, and you obviously can check your answer on these, if I get a common denominator of 90 over 90, this would be 90 and 18 and 5 over 90. I think, is that 113 over 90?
Yeah.
Is that what y'all got? And you can divide 113 by 90 and see if you get 1.2555555. Does that work? Did your homework? You get 113 over 90?
Yes.
Okay. All right, Isabella, questions on that? Okay. All right. So let's do a practice one. What would happen if I wanted 4.2538 and just the 38 is repeating? Automatically, I need a 38 over 99 to make it go 383838. But I also want to move it over how many places before I start that? Do you see I have like 2 placeholders? If you divide something by 100, doesn't it scoot it over 2 decimal places? If you actually type 38 over 9,900, you'll get this, 0.00, and then it'll start with its 383838 like we want it to, okay? Then I add on the 4 and the 25 100ths, okay? And you could get common denominators, or you could type it in your calculator like this. Let me pull up the calculator. And on the exam, just like on some of my tests, there may be a non-calculator part, but it wouldn't be anything that you weren't totally prepared for. But anyway, I should be able to expect you to add fractions together with or without a calculator. But if you have a calculator, here we could go 4 plus 25 100ths. Sorry, it takes a while to open up. while we're waiting to open, think of other homework questions or old homework questions off of worksheets or book. And let's focus just on homework right now and not exam review. Wow, shouldn't take that long. Okay. So, I think I had, now it's stuck on the pen. Let me get to the pointer, see if that'll work. All right, so, by the way, I was helping somebody, I can't remember if it was somebody in here, the other day about like, now I want to go to my home screen. And some people I found out are turning their calculator on and off to get to their home screen. I just go second quit and go to my home screen. So anyway, whatever that's worth. All right. So I'm going to go 4 plus 25 over 100 plus 38 over 99 will make it go 383838. If I go 990, it'll make it go 0.0383838. But I wanted to reserve 2 places because I already had the 0.25. And then you can go back to math fraction, and it'll give it back to you in reduced form. Apparently, that's as low as it could go. So if I made if I made my common denominator 9,900, apparently that's as low as your fraction will go. It looks like it wouldn't have reduced. Y'all all know how to tell if something's divisible by 3, don't you?
Yeah.
If you add up the digits and you get a multiple of 3. You would have to show your work on this on the exam or on a quiz, okay? Again, you might have a quiz on this. I just want to give another quiz before the exam. I hadn't decided what I would put on it, but again, I will let you know. But you would have to show your work because I want to make sure that you know how to write the repeating decimal, not that your calculator knows how to write the repeating decimal. But I wanted to go over that because I don't mind once you do your work if you realize how to reduce it. Like for instance, if I had something like 117 over 99, okay? And I hit enter, I get this cool repeating decimal, 1.181818. It's only rounded at the end there because it's programmed to only give a certain number of decimal places. It's just how it's programmed. But if you go back to math fraction, it's just kind of nice to know for standardized test taking. Do you see how it brings it back to you in reduced form? Okay. So if you have a fraction that you want to reduce, then you don't really need to show anyone that skill. You can put the big fraction in, get your decimal, and then go back to math fraction. It'll come back in reduced form. You may have known that. Okay. So is that okay? Is this good? Okay. There's just a superset way you can do it without going back through the formula, I hope you know that I'm getting all of this from the formula of the sum of an infinite geometric series. Okay? Elena?
Is there a way to write, like to make it repeating without having to type it in like over and over and over again?
I don't know of a way to like put a bar over it or
Okay.
anything. There may be one, but
Okay.
I've not ever needed it
Okay.
or been in a situation where someone would let me use it.
Okay.
Does it work to actually type it in for a long time and then it gives you the fraction?
Yeah.
That's why you got to show your work.
Yeah.
So, yeah, I guess I'd just be thankful for that much.
Yeah. So can we not use the formula that you gave us?
Oh yeah, you could. You could totally show your work. You could show your understanding by just doing what I did right here. And then, show your common denominators, okay? At least show this to where I know that you know what's going on. And you didn't just go 1.255555 math fraction, okay? But if you want to actually go back to like how to work it every time, 1.25 repeating, we have 0.05, 0.005, 0.0005, on and on forever. And so Pietra, her A1 would be 0.05, but your ratio is really just 0.1, isn't it? Okay. This is a question I got from somebody also, by the way, so listen up. 1 minus 0.1 is 0.9. Somebody emailed me like, I keep getting like multiples of the fraction that they were getting using the formula. And I'm like, oh, well, you're allowed to do a lot of things. Like you can have square root in the bottom. I don't even, in AP calculus, we don't even care necessarily that you reduce your fraction because we'd say your answer's right. But we don't allow complex fractions. An acceptable fraction would be an integer over another integer, okay? Don't leave a decimal in your fraction or a fraction in your fraction. That is not acceptable because it's just so unfinished, just so misleading. And so I wouldn't take this as a fraction. And so we would have to move our decimal over 2 places to get an integer. And then so that's where I'm getting that number. I've done it enough, mathematicians are always on the hunt for a pattern. And that pattern always works, but you can definitely use the formula. Don't forget to go back and add it to the 1 and the 2/10. All right? It's a really cool thing to know about repeating decimals. Other questions? Okay. Now, some of you have brought this up. Like the dilemma is 0.9 repeating is 1. It's very upsetting to some people, but 0.9 repeating is 1. If I needed to do 0.7 repeating, we could use the formula, but we know we would get 7 over 9, I think, okay? If I use the formula here, I have 0.9, 0.09, 0.009. We know that the formula works, so we can use it over and over again. So I have a sub 1 over 1 minus the ratio. So you have 0.9 over 0.9, which is 1, which is great because like I said, as you go further into calculus, you get to be sort of less and less of a math nerd rather than more and more of a math nerd. You're not the person that's sitting around going 3.99999999999. You just go 4. Okay? If you have 3.9999999999999 slices of cake, you've got 4 slices of cake. Okay? So anyway. I don't know that we could tell if we took away or added a crumb. It's a great way to let you live in the real world. And we're not lackadaisical about it. I'm not saying like 0.9888742 is 1. Okay? So it's an interesting concept. Isabella?
So you're okay with either way, that formula?
Yeah, the formula or the trick. I just have to see, because the trick is based on the formula. And so I have to at least see this, okay? So just to review, if you have 0.3426, okay? So I'm going to have 6 over 9 because I only want 1 to repeat. I'm going to hold 3 places, and I'm going to add to that 342 over 1,000. That make sense? And then figure out my answer from there. I have to at least see that. If you back it down to the formula and feel better using the formula, you would end up with this and then go forward. It's a great discussion about complex fractions in the formula. This formula, a sub 1 over 1 minus r, it's really important if you have a sigma, which I think we need to go over some of the old homeworks, or maybe the one last night, at some point where I've asked you to add up a certain number of terms in a geometric sequence. You've got to make sure you know what the first term is. And I think in our last class, when we were upstairs, I talked about this. Like, for instance, I probably should look at one of your homework. But and let me do this, and I'll take some more questions. Okay. If I have the sum as k goes from 3 to infinity, and the formula is like, let me think of one, 2 to the k power. If I start to write it out, 2 to the third is 8, 2 to the fourth is 16, 2 to the fifth is 32, 2 to the sixth is 64, and on forever. And you want to, that one, I'm sorry, you couldn't add up, so forget that. Because r is not less than 2, r is not less than 1. Do y'all see what I mean? I messed that one up, okay? So let's make this 0.2k, where my absolute value, my ratio is less than 1. So now I have 0.2, so y'all help me with this. 0.2 to the third would be 0.008 Or what's 0.2 to the third? Is that right? 0.2 to the third is 0.008?
Yeah.
All right, and 0.2 to the fourth is 0.00, probably 16. Isabel, will you check that?
Yeah, it is.
Okay. And so on and on like this. When you're using the formula and you want to add up all of these numbers, you've got to make sure you know what your first term is. I don't care where K is starting. You need the first term in the sequence you're adding up. My point is, if K is 3, you don't have to go back and find. If you're thinking that as A sub 3, that's not what I'm talking about. I might need to just be quiet. I might be confusing you more than helping you. But it can be confusing sometimes where people think, wait, I started at 3, so does my formula require that I go backwards and find out what happened when K was 1 for A sub 1? So the language can get kind of confusing sometimes, okay? But if I actually want to add up this series, I need the first term in that series. So I need 0.008 over 1 minus my ratio, which is 0.2, and that would find the sum of that series, the infinite sum. Okay? I think that, and this is the infinite sum. Let's talk about the other formula, which I may or may not derive for you today. 1 minus r to the n. It's kind of cool. It's super cool. If I could get it right, it's super cool. Okay, this is the formula for an infinite geometric series. Girls, listen up. You actually could use this formula and get the same answer as if you use this formula. Okay, so if I want the sum of an infinite number of terms, my first term, a sub 1, is 0.008. Then I'm going to have 1 minus 0.2 to the infinite power over 1 minus 0.2. If I use that formula. I'm not a fan of that. I wouldn't do that. For one thing, you should think to yourself, well, I can't even type in 0.2 to the infinite power. But look what was already happened with Isabel and I. 0.2 to the third was already 0.008. 0.2 to the fourth was 0.0016. 0.2 to the fifth. What's 0.2 to the 100 is going to be infinitely what? It's going to go smaller and smaller and smaller to where it's not going to make a dent in that. It's going to be, oh yay, I have a cookie. And somebody comes and takes an atom away from that cookie. Okay, you're not going to be proud of that. You're not even going to know. So
Oh, I know.
Well, remember when I poked a hole in my sweater when we were going over rational functions? I mean, you don't know when that happens. I had one entire, this one has holes all in it, so I can't talk about it, but my pants. I have, one pair of pants on, but I would be glad to pick up something and poke a hole in it, and then I would have, we know there's a hole in it, but you wouldn't go, well, let's throw away the pants, okay? So anyway, after that stupid example, this gets infinitely small, and so you're going to say 1 minus 0.0000000000000000000. So do you see how you would still get the same answer if you type this in? Okay? Don't though, if you're going off to infinity, do you see how this formula morphs into just a sub 1 over 1 minus r?
Yeah.
Because this gravitates closer and closer to a word that we're going to study after the exam called limits. The limit of this is just getting closer and closer to 1. Think of 1 minus 0.008, 1 minus 0.0016, 1 minus 0.00032, 1 minus, just getting closer and closer
So
to
then
1.
it's just the same thing as a sub 1 times 1.
So people knew this part would just disappear, and you would have a sub 1 over 1 minus r if you go to infinity. Okay? It's really exponential growth, which I almost hate to bring it up. It's exponential decay right now. Like if I have 0.2 to the x power, and the reason I hate to bring it up is it makes us think of what's happening with the coronavirus. So if I go to Desmos, and one of the parent graphs that my Algebra 2 class is working on right now is 2 to the x. it'll grow out of bounds if your ratio is greater than 1. So if I have 2 to the x, exponential growth. Unfortunately, that's sort of what's happening right now with the coronavirus. But if I make my ratio less than 1, I'll have what we call decay. Do y'all see what I mean? And so already at 2 and 4, it's so teeny tiny that you see what's happening as x gets, look what Desmos is already calling
It's
it.
already at 0.
It's not quite at 0, but the number's so extremely small, it's rounded it off to 0 already. It happens really fast, that exponential decay, for whatever that's worth.
So y is going towards 0 as x goes to infinity?
Yes.
But like, it pretty much is just 0.
There's a tool that we use in calculus that you'll use in the end of honors pre-calculus called a limit that lets you just go ahead and call it 0, okay? Which is nice. It's really nice. And I'll bring that up when we go and review rational functions. It has to do with that too. Where something's gravitating like a horizontal asymptote, it's gravitating closer and closer and closer to something. In fact, it might even hit it, which a couple of people have already looked at in their review. Let's go back to any other homework questions that you have on anything. Hopefully you've like marked or highlighted or put question marks as the days have gone by when I keep piling more stuff on you. It looks like you have. Mary?
On page 596, 67.
All right, 67, 596, 67. All right, 67 is 2 minus 1/2 plus 1/8 plus ... 1 over 2048. Okay, and the question is, use summation notation to write the sum, and then maybe even define the sum. All right, so it looks like, well, I could find my ratio by saying a negative 1/2 divided by 2, which is negative 1/2 times 1/2. I think a lot of you can see that your ratio is negative 1/4. Okay? And so I'm going to say the sum, I don't know if I'm going to use N or K or I or what. I avoid I because it makes me think of imaginary numbers. I'm going to just use N right now. As N goes from 1 to I don't know what, I'm going to have to find out how many terms there are, which may be kind of the issue here. So I need to know what my last term is. I need to know how many I have, like where to stop. So I'm going to say my last term, I'm using this formula. I'm not using a formula, I'm using common sense, which I'll talk about in a minute. But A sub n is equal to A sub 1 times the ratio n minus 1 times. That's your geometric term formula, and you can find out all things about your terms with that. I know that somehow I got to 1 over 2048 by starting with A sub 1, which is 2. I know my ratio is negative 1/4 to the n minus 1 power. So I'm going to multiply that one. This is a great question. I'm going to multiply by 1/2 and get 1 over, I believe it's 4096 is negative 1/4 times n minus 1. Now for right now, I don't care if you sort of guess and check. That's okay for a mathematician to do. Lots of people in research are doing that. The reason that I'm okay with it is because a lot of times your intuitive sense is so mathematical that it may be better than working it out with logarithms. Okay? If you want to get to an exponent, you use logarithms. I'm super okay with you messing around with this though. First of all, I know n. I know I get a positive number. So n minus 1 together's got to be an even number. That means n's got to be an odd number. So you might want to try like negative 1/4 to the 8th and see what you get. Negative 1/4 to the 6th and see what you get. What is it? So n minus 1 is 6. That is fine if you do that. That shows a lot of understanding of what's going on because as soon as you pick a number, you sort of know what ballpark you're in. Okay? I'm okay with that right now. And so if you kind of guess and check, this has to be 6. And so n minus 1's got to be 6. And so n is 7. All right, so I'm going to go from 1 to 7. Now we're still not through. We got to be able to write our formula back here. I'm going to start with 2, and we're going to multiply by negative 1/4. And I'm going to make this n plus 1, minus 1. The reason I made it n minus 1 is if I filled in 1, I would have 2 times negative 1/4 to the 1 minus 1. So I'd have 2 to the negative 1 times negative 1/4 to the 0. That would start me out at 2. The next one would be 2 times negative 1/4. If I fill in 2, I get negative 1/4 to the first, and that would give me my negative 1/2, and it would start clicking through like that. There's other ways you could write this. I'll have to grade what you write. There's other ways to write that sigma notation, and you can ask me them if you want to in just a minute. I want to back up, and you do need to know from your algebra, whenever you are looking for an exponent, that's what logarithms and exponents are, inverse operations of each other, okay? And so if I'm going, I want to know what that exponent is, I can use a logarithm. Actually, you'll see in calculus that we use base E a lot, the ln button. It doesn't matter which one I do. A logarithm is going to help me tackle that exponent. You can use a log to any base. I'm going to take the natural logarithm of both sides because that's just what I do most of the time in calculus. ln of negative 1/4 to the n minus 1. What do you do with the little thing up in the air?
Oh, you do the little bicycle.
I don't know about that. You bring it down in front. Apparently it's a bicycle. All right, so that gives you ln of 1 over 1,096. Oh, is that 4,096? 4,096 is equal to n minus 1 times ln of negative 1/2, which I'm nerdy enough to know is negative 0.693, but let's move on. All right, so now I can solve for n by saying, where's my calculator? So I can take the logarithm, I'm using ln, of 1 over 4,096 divided by ln of, what was it? Negative 1/2.
Oh.
Why is it negative 1/2? Did I write that right? Oh, God, I'm sorry, girls. My numbers they're all morphing into something else. Sorry about that. Let me go back to this real quickly. Okay. Everybody look up here. Quit talking to your neighbors. All right. I wouldn't be going over this if, as an honors pre-calc teacher, I'd expect you to know any algebraic tool to solve a problem. So pay attention. Another reason I want you to pay attention is to catch my mistake. This negative 1/4 morphed into, I think, a negative 1/4 right there that to me looked like a negative 1/2 because I write so poorly. So this is actually a negative 1/4 in here, which I'm not nerdy enough to know, I'm proud to say. Okay, so now let's go to the calculator. So this is negative 1/4. And what did I do? Oh, negative. Sorry. I used the minus instead of the negative. Oh, still. Oh, you can't take the logarithm of a negative. Yeah, let me show you that. Logarithmic functions look like this. Logarithmic functions go like this. They're the inverse of exponential functions. Like they flip over the line y equals x if you've studied inverses very much in algebra. So my logarithmic function can't be negative. It's not, I'm going to get an error every time that I do that. So let me think what I'm going to do. You really are wanting to know this. Could I just use 1/4 to what power? Yeah, because it's even. So let's do that. Sorry, you can't have a negative next to the word logarithm. So let's try to get this. Okay, so that gives me n minus 1 is 6. All right, so let's pause for a minute. Suppose you're doing something like this, and you know that you have a number like 60, I don't want to use 64. Let's say 343 is negative 7 to the n power. So I could use logarithms and go the logarithm of 343 equals the logarithm of negative 7 to the n. The logarithm of 343 equals n, but I'm not going to be able to say the logarithm of negative 7. So do you see temporarily I'm going to help myself find n just by calling it ln 7, because I'm never going to be able to find it with a negative exponent. I think I picked one that I can actually work. Let's see. ln of 343 divided by ln 7. Yeah, so it's 3. All right, so I know that n is 3, and that wouldn't even make any sense in this case. So let me fix it. This would be a negative. So what I'm saying is if you start at negative 7, and you're multiplying by negative 7, you get 49 times negative 7 is negative 343 times negative 7 is whatever. What I'm saying is if you just want the number of the term, you can leave off the negative for a minute until you find out how many of them you need. Because you got to land on that number one way or the other by multiplying by 7 or negative 1/4 or whatever. You can't have a negative next to the word logarithm. We're going to work on logarithms some more later in the year because they're so prevalent in calculus. But let's backtrack and go, I'm okay with you doing some very intelligent guessing and checking. I think that's really, really good that you have a sense that you can find it that way. That's really good. All right. But I wanted to go ahead and do that logarithm. Mary, great question. So you're probably more, not you individually, but most of you are probably more at this point right here, where you can start to take negative 1/4 to the whatever powers to get 1,496, 1 over 4,096, and then once you know it, you can fill it in.
So I just have a question.
And we can do another one like that without that much discussion.
For like the one with like the negative 343, I understood why you like made those positive.
Yeah.
But I don't understand how for this one you made the 1/4 positive.
Because I just want to know how to get from one place to the next. Like right now, I really just care that it's going 2, 1/2, 1/8. I can pick up the alternating part later. I just want to know how to land on that number.
Okay.
I can get the alternating part later. So let me back it down some, and then I'll take another question. If I had, like if I had 1 over 3 minus 1 over 9 plus 1 over 27 ... I'm just checking to see if I would land on a positive or a negative when I hit this number right here. All right, so I land on a positive. Okay, so and Mary left, but maybe we can tell her to start with like the aqua slide because this was her question. what's my ratio here? All right, it's technically negative 1/3, right? But right now, I just need to land on that number. I don't really care if it's positive or negative right now. In fact, maybe I should have picked out one that was actually going to land on a negative. But I just need to know 1/3 to what power is going to give me 1 over 177,147. Like I'm going to say, I have my first term times negative 1/3 to the n minus 1 power equals this number, 1 over 177,147. And then I'm going to multiply by 3. And I have 1 over 531,441 equals negative 1/3 to the n minus 1. If you're using logarithms right now, just don't put in the negative 1/3. Leave it 1/3 because you're going to get to that number. You can put in the negative later. I don't know if I'm saying that very well. I'll do it with another number in a minute, but let's just finish this one. What do you want to guess? Negative 1, because I think most of you are going to guess and not use logarithms.
Yeah.
Negative 1/3 to the 10. Oh, I'm sorry. We really need
I just do 3.
3 to the 10. Is 5,049. I mean 59,049.
So much.
It's the
Yeah.
3 to the 12
Yeah.
is that number. So now you know that n minus 1 is 12, and so n is 13, which I didn't think it was.
Why did we do 3 instead of?
Because then it's like you would have to figure out the decimal that you're getting close to instead of just doing 3 to the bottom.
Like you want this bottom to turn into 531,441. And so it's a little easier than dealing with the fraction if you have a 1 on the top.
So we're allowed to do that? Just like guess some.
Yeah. Yeah. People do that all the time. People that are really, really good at math are really, really good at estimating and getting to something really quick. In fact, like some, I don't know if anybody in here is on the math team, but in the math team, like a lot of times that's the quickest way to get to the answer and be the one that gets the answer right. Or in your jobs, you have a sense of what's going on and you work it. That's fine with me. I think that's a great tool.
Yeah, no, if you watch the
Um,
videos of competitions,
yeah.
the kids just answer them before the questions
Even asked, yeah. It's crazy. I just didn't think n was 13. What's 1/3 times negative 1/3 to the 12th? Negative 1/3 to the 12th. And then go math fractions. All right, do 1 over 177,147.
It's different.
It's different.
I did the log too, and it
Because
still
it's
was
negative?
13.
No, hang on just a second. Did you get 13 that way also?
Yeah.
1/3. So when I say 1/3 times negative 1/3 to the 12th, I should get that number, right? But we're not. 1/3 is my a sub 1 times our ratio to the n minus 1 power. Let me look at this. 1/3 times negative 1/3 to the 12th.
Oh, well, shouldn't you get a smaller number? Like, don't you
I think it's
time?
sweet.
It's like 1 over 177,147 times 3.
I got.
So wouldn't you get 1 over a number smaller than 177,147?
It should tell us the number of the term, though, is what I'm saying. Like, see how I set it up? I said I took a sub 1. I multiplied by negative 1/3 to the n minus 1 power to see where I was landing, to see how many terms I had. But maybe what you're saying is right. I'm not seeing what the problem is. I think n should be, hang on, let me try something.
It doesn't even give me a fraction. No, because when you
Yeah,
you should get a number smaller than
I think it's because
17747.
when you divide by 1/3, you're multiplying
By 3.
177 by 3. So it'd be smaller than what it is up there.
Yeah,
Oh, I didn't multiply by
Yeah.
3.
I think
That's
you
what I did
times
wrong.
the bottom.
Thanks. I times the bottom by 3. I should say 177,147. So that should be the 59 on this. Another mistake. Sorry. All right, girls. I could claim that I'm doing all of this to make sure you're paying attention, but I've actually made 2 mistakes. So don't get in too much of a hurry. I was doing things in my head. Thank you, Elena. I should multiply this side by 3 and this side by 3.
So don't you divide,
And so-
divide the bottom?
Yes. And so you get 59049.
No, you divided the top by 3 to get that. 'Cause when
That's
you,
what I want to do because 3 goes into that how many times?
Oh yeah, 59049.
And that would be negative 1/3 to the n minus 1.
Oh,
So now 3 to what power gives you 59049? 10. So n minus 1 is 10.
yeah.
And so n is 11, which is what I'd originally planned. Okay? So girls, once again, my mistake is when I multiply by 3, I multiply the bottom by 3 and not the top by 3. So it's probably best to write your algebra down. Okay, so anyway, I think Mary's probably main question was how to find your number, but then also somebody else may have a question, or she might, about my sigma that I went ahead and set up and wrote it in summation notation. And so after all that work, mine was this right here. Red's not going to work there. That was my sigma notation. Any more questions on number 67? Okay, 67. So you're good on that?
Yeah.
Okay, Elena?
Number 93.
All right, this is 93. All right, 93, we have the sum of 6 times 0.8 to the n, as n goes from 0 to infinity, written really poorly. All right, so determine whether the sequence is arithmetic or geometric. Find the common difference or ratio, and find the sum of the first 15 terms. This is real important. This is one thing that I was saying. First of all, if you want to start writing out a few terms to help you decide if it's arithmetic or geometric. I highly suspect geometric because of the way it's written, okay? But my first term is going to be 6 times 0.8 to the 0, 6 times 0.8 to the first, 6 times 0.8 to the second, and so on. So my first term is actually 6. My next term, I guess, is 4.8, and I'm not going to guess the next term, but it's something blah, 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 okay? And so I feel like it's geometric, so let me make sure I answer all the questions. It's geometric. The common difference or ratio, the ratio is 0.8, and I want the sum of the first 15 terms. S sub 15 is equal to A sub 1 times 1 minus the ratio to the 15th power over 1 minus the ratio. And make sure you put in the first term, which is 6. So always look at where it starts counting by and make sure you get the first term in that series. So let me type that in. Made enough mistakes today. Let's see if I can get this right. All right, so we have 6 times 1 minus 0.8 to the 15th. Well, I usually don't put in my 0, but it's 0.8. I should put in my 0, but I usually don't. Divided by 1 minus 0.8 should be 0.2, shouldn't it? I don't know what the answer is. I got 28.944. All right, so questions on that one? Hey girls, everybody look up here. I've seen people miss this by just grabbing this and putting in a 1 for n. That's what I'm trying not to confuse you if you weren't ever confused before. so I need to kind of back off of it in a hurry. But the big deal is that we really mean the first term that you encounter in this list. So just list out 2 or 3, so you actually know what the first term is in that series. Okay?
If it's like greater than 1, then you start at 1, right?
No. If it said this, if I have this one as the sum of 6 times 0.8 to the n, and n goes from 3 to infinity, I would go 6 times 0.8 to the third,
Oh, okay.
6 times 0.8 to the fourth, because think about what they're asking you to do. They're asking you to add up all those numbers. So I need the first one of those numbers.
So a sub 1 in that is.
Yeah, that's why I said the nomenclature can be confusing, because a lot of times when I say that, sometimes if I give you a sub 3, I want you to find a sub 1. But the best way for someone to write it to you is I need the first term in the series that you're working on at the moment.
So that would be a sub 1 in that?
This one would be a sub 1. Okay?
If it says find the first 15 terms and you use a of 0 as the first term, then do you make it instead of 8 0.8 to the 15 power 0.8?
No. No, what you're doing is this summation, this right here is having you add up a bunch of numbers. Okay? And so you need to know what the first term in that series is, and then what your ratio is. So you don't need to change anything. Like, let me show you this. If you have the sum of 2n as n goes from 4 to 8, 4, 5, 6, 7, 8, okay? So I should have known there were 5 terms there, because you can subtract and add 1. All right, if I write it out, I have 2 times 4 is 8, 2 times 5 is 10, 12, 14, 16. Let's add that up. That gives me 30 and 30, so that gives me 60, okay? If I use the formula, I'm going to say a sub 1 is 8 over 1 minus, sorry, it's not infinite. I'm going to say a sub 1 is the first term in this sequence. I just started counting at 4, but I'm going to call that a sub 1. And then I'm going to say 1 minus the ratio, which is 2 to the 5th power over 1 minus 2. See if I did that right.
So that's finding the terms 4 through 8. But if you found
Oh, I see what you're saying. Let me go back. Yeah, I see what you're saying now that I've made up that one. N is 0 to infinity, and they want the first 15 terms. Oh, you still would do that, because you still would start with this one, and you would have 15 terms.
so it's 15 terms after that and you wouldn't count.
No, it's not 15 terms after that. It's including that one.
Like n equals 0 is the first term.
N equals 0 is the first term.
So how would you make it 15 if the little number, if the exponent is supposed to be the minus?
Hang on just a minute.
Oh, if it's like n minus 1.
Yeah.
Okay. So I'll come back to that other one in just a minute. Let's do this one. As n goes from 0 to 4 of 3 times 1/3 to the n power. So I have 3 times 1/3 to the 0, 3 times 1/3 to the first, 3 times 1/3 to the second, 3 times 1/3 to the third, and 3 times 1/3 to the fourth. So now I'm not even looking at that anymore. I want to add up these 5 terms. All right, so my terms are going to go 3, 1, 1/3, 1/9, 1/27. Okay? So what I'm going to do is I'm going to say a sub 1, which is 3, times 1 minus my ratio, which is 1/3, over 1 minus r. And how many times did I multiply my ratio? Oh, you're still running into that. I see what you're saying. Because now I've multiplied by my ratio.
4 times.
Which means if you want to
So then it's, I think if it's n equals 0, you have to multiply by 5.
This has never confused me before, so hang on. The sum of 15 terms, you're starting with this one, multiplying by that 15 times. Sum of 15 terms. Okay, it's the wording. So if I want the sum of the first 5 terms, and somebody explicitly says the sum of the first 5 terms, then the first term in the series is 3. My ratio is 1/3 5 times. I'm not looking at my indexes up there anymore.
But say you were just given that, you would still have to do 5 because you're going from 0 to 4, which is 5.
Yes. But it says the first 5 terms, so you don't really even I don't have to write them all out.
Right.
How would your ratio, but you're only multiplying your ratio 4 times.
Yeah, but if you have the sum of 5 terms,
Oh, but you're also dividing it by 1.
it's how I haven't shown you how they derive the formula, Rebecca, and now hopefully I will one day. But this is one of the few formulas that doesn't have an n sum 1 in it. See, here's your formula. The sum of 5 terms, that would be an r to the 5th power. You don't do an n minus 1 on this. The formula is set up to say a sub 1 times 1 minus r to the n over 1 minus r. It's not an n minus 1. It's how many terms do you have you're trying. If you're adding up 20 terms, n is 20. So the easiest thing to do is just start writing out your list and use that as a sub 1. You know your ratio. However many terms I tell you to add up is your n. Does that make sense?
Yeah.
It can be confusing because of the terminology that we use. Homework for, I was gonna maybe start something new today, which obviously didn't happen. But it's good discussion. And I think, Katie, did you have a question you didn't get to ask?
the same one there.
Okay, so it seems like the same one that y'all struggled with. I'll give you some similar problems to work on, just a few. You can start your exam review. And also, you will have a quiz. And I'm gonna sit down and decide what I wanna put on the quiz, and I'll tell you exactly what to study for that. Okay, if Delta Math, I'll give that a shot. Our next class, you know, maybe what's the name? I asked about it.
It's still don't say it.
Yeah. So we'll need
What are they deciding, like the size? Also base, your fault. Be able to put it down.
Not the side. Oh, that's not gonna
Is
happen.
the size always the 3x4